Hi everybody, you're watching 7.6 average rate of change notes. And I don't know if you can see this. I'm pretty sure you can see everything on my screen. I put a picture of the sleeping dog. She's the one that's usually barking, but she went for a walk and she's extremely tired. And she's lying on my arm, making it hard for me to write. So we're going to do the best we can to get through average rate of change. Keywords, rate of change. I know you guys have heard this before. Average rate of change, is this just the slope between 2 points of any function. So I like to think of a rate as a ratio. And when I think of a ratio, I think of a fraction. So average rate of change. On the top, you're going to have the change in y. And in the bottom, you're going to have the change in x. Okay, I know that's messy, but like I said, the dog's on my arm. First, identify the type of function that is shown. So we're going to look for the type of function, then we're going to write the equation, and then we're going to find the average rate of change over the given domain, which is x values. So number one, this type of function, let's see. It goes like this. That looks like a linear function. The equation of that, well, if I'm thinking about mx plus b, because that's the equation of a line, I would need the slope and the y-intercept. So the slope is, let's see, well, the y-intercept is 4. That's right there. So plus 4 at the end. So y equals the slope in front of the x. Let's see, we go down 1 and over 3, down 1 and over 3. So down 1 over 3 in front of the x. So negative 1/3 x plus 4. All right, so the average rate of change, well, it's a line. So the rate of change is constant. And I already told you what it is because I counted it out in the picture. It's negative 1/3. But let's just check it out and make sure. So if I put this domain, these x values in a table, negative 6 and 3, and I look for their range, their y values, at negative 6, the graph is at 1, 2, 3, 4, 5, 6. And at 3, 1, 2, 3, the graph is at 3. So if I look for the rate of change, I'm looking for that fraction, this y change goes down 3. So that's negative 3. I thought it was going to be negative 1. Something weird is happening here. This increases from negative 6 all the way up to 3. That's a change of 9 units. And then that would reduce to negative 1/3. Any 2 points that I go between on this graph will have a slope of down 1 over 3. Question 2, what type of function is this? Well, it goes like this. That is a parabola, but the type of function is quadratic. The equation, let's find the vertex. The vertex is at 1, 1, 2, 3, 4. So the vertex is positive 1, negative 4. And I got to have an x squared, so the parent function is x squared. So my equation is y equals, make sure if it's asked for an equation, you put y equals. You have x minus 1 squared. Change the sign on the x value. Don't change the sign on the y value. So minus 4 on the outside. Okay, we're looking for the average rate of change. So I'm going to make a little table with these values that they gave me. They gave me the domain, which is the x values. And we're going to put the negative 2 and the 2 in the table. Find the y values. And look at our graph. At negative 2, the graph is up at 1, 2, 3. My pen stopped working. 4, 5. And at 2, my graph is at negative 3. So I need to determine the rate, which is a ratio. I'm doing y minus y to find out how much change I have in the y's. From 5 to negative 3, so dropping from 5 to negative 3 is a drop of 8 units. 5 minus negative 3. Yep, that's 8. And to rise, so that was a drop of 8. This came out positive, though. That means when this one rises, and I would have said that this was a, let's see, negative 2 all the way over to 2 is a change of 4 units, and that was an increase. So this was negative when this was positive. And if I do negative 2 minus 2, I get a negative 4. Yeah, when this is negative, that's positive. When this is positive, that's negative. Anyways, the change is negative 2. 8 divided by negative 4 gives you negative 2. I hope I didn't just screw you guys up with those signs. Let's do another one. Okay, number 3. It says type of function. Well, it's a V-graph. It's absolute value graph. Equation, y equals, I need the bars because the parent function is the absolute value of x. I need the turning point, 3, negative 5. Oops, sorry, positive 3, negative 5. So it's going to be x minus 3 minus 5. The slope stayed 1, so there is a 1 in front of here if you remember that. Rate of change from 1 to 5. Okay, let's look at 1. Here's my slope, or here's my point on the graph. And 5, here's my point on the graph. Oh, look at that. It looks like it doesn't change between 1 and 5. I think it's going to be 0, but let's check out the table. X, Y, 1, 5. 1 is negative 3. 5 is also negative 3. So this change is 0. This change is up 4. So my Y changes are 0. My X changes are positive 4. 0 divided by anything is 0. Okay, next one. If you remember this graph, this looks like the square root of x graph. So this is a square root function. And the equation then would be y equals the square root of, all right, let's see, where's the important point? Negative 5, negative 2. So x plus 5 and minus 2 outside. Average rate of change from negative 4 to 4. Let's look at where those points are. Negative 4 is here, and 4 is here. So we could go rise, run, 2, 1, 2, 3, 4, 5, 6, 7, 8. Let's look at a table. I think I know what it is. We got negative 4 and 4. And at negative 4, we're at negative 1. And at positive 4, we're at 1. Which means, here's my ratio, change in y, that's increasing 2 units. I saw it on the graph, and now I'm seeing it in the table. These are going an increase also from negative 4 to 8, an increase of 8 units. I saw that also on my graph. So we have 2 over 8, which is 1/4 if you reduce it. And it's positive. If you look, you are definitely increasing. So it makes sense that my rate of change came out positive. All right, let's turn the page and try a few more. What? On this page, 5, 6, and 7 don't have any graphs. So how am I going to count them out? How am I going to look for rise over run? Well, one thing you could do, first identify the type of function. Okay, well that's easy because we got the square root, the bars. Those will be easy to do. Find the average rate of change. I remember that's a rate, y minus y over x minus x. Remember, it's a fraction, it's a rate. All right, so let's graph these on our calculator and calculate the rate of change. That was my idea. All right, type of function. First of all, this is definitely a quadratic. I knew that because of the parent graph. I see the x squared, it's a quadratic. Over the domain, I'm looking from negative 2 to 1. Remember, domain is the x's. So I put those in the x column on my table. I'm going to go to my graphing calculator and graph x squared minus 3. Here's my graphing calculator. No, I lied. Here's my graphing calculator. X squared minus 3, I think, is a page or two over. x squared minus 3. There it is. And we are looking from -2 to 1. So -2 is 1 on my calculator, and 1 is -2. So I need the 1 and the -2 on my table. This gives me a 1. This gives me a -2. All right, how much of a decrease is this to go from 1 down to -2? That decreased 3 units. So you could say -3 on the top. This, if you think about going from -2 up to 1, is an increase of 3 units, +3. Altogether, I came out with -1. If I divide, -3 divided by 3 is -1. Okay, another way to look at this, you could do the math. You'll still get -1 if you do 1 minus -2, and then over here, -2 minus 1. So on the top, I get 3. On the bottom, I get -3, which is -1. Okay, next graph. Type of function? Well, it's a square root function. Very easy to see because I see the square root symbol. I'm looking at my table to get my rate of change. My x's, my domain goes from 9 to 17. I'm going to look at my graphing calculator. The second page, I graphed this already. At 9, it's 2. So this is a 2 in the y column. And 17, I gotta look for 17, huh? Let's scroll down. It's 4. So remember how to graph these things on your calculator. The hardest part about graphing this, by the way, when I went to the function line and I typed in x minus 8, I had to stop and arrow out of the square root before I did my +1. Sometimes that's tricky for people, forget to get out of the square root. All right, let's look at the rate of change. This is increasing by 2 on the y's, so +2. And on the x's, we are increasing by 8, +8. So if you reduce 2 over 8, 1 over 4. And your calculator would reduce that for you if you put it in. Okay, my arm is now falling asleep. My dog is very heavy on my arm. All right, so now we're looking at the absolute value function here, absolute value. I'm going to set my table up before I go to my calculator. I'm looking from -4 to 3. That's the domain. I'm going to look at the graph. I'm going to take a look at the picture for a second, too. So let's look at this. Control, next page. I already typed in the function. I'm looking for -4 is 0. So -4, 0. And then I'm looking for 3. 3, if I go down to 3, 0, 1, 2, 3, 3 is 2. So -4 to 3, 2. If I look, it looks like it's going to be a positive increase from there to there. So let's check it out. 2 is the y value here. That's an increase of 2. And yep, this is also increasing. So if I was 4 units below 0 and I went up to 3, that's a +7 increase. I always think of a thermometer. I was down at -4 and I had to rise all the way to 3. I'd have to pass 0, so that was 4 spots, and then 3 more. So it's a total of 7 spots that I went up. Anyways, my change, my ratio is 2 over 7. That's my rate of change between those 2 points. Okay, this last question, they give me 3 different intervals. 1, 8. An interval means we're going in the x direction, and we're looking for the rate of change. It doesn't always mean you're going in the x direction, but in this case, that's what they're assuming. So from 1 to 8, so I'm going to look at those points, 1 and 8. I'm going to make a table because it's easier for me to see things. At 1, oh my God, wait a minute, am I still recording? I just thought I wasn't recording anymore. I scared myself. Okay, anyways, so I'm looking at 1 is 91. Oh, these are weird numbers. Hopefully we can handle this math. And at 8, with a dog on my arm, sound asleep, to 84. All right, so I just looked at the coordinates that they gave me. made a table out of it. This is a decrease, and I can kind of see that it's a decrease because that line is going downhill. It's a decrease of 7 units. I think that's right. And this is increasing 7 units. So my rate of change is -7 over 7. Oh, that's just -1 if I calculated it. Okay, next one, from 0 to 11. So x's, 0 and 11. Let's look at y's. Do this one in red. 0 is 84, and 11 is 51. Again, it's definitely going downhill. So I like to take a look at it on the graph. I got 84 and 51. So my rate, y's first, right? That's going to go down 33. I just real quick did 84 minus 51 in my head. And then this, your x's are going up, so x is on the bottom, going up 11. And if you were to calculate 33, wait a minute, 84 down, oh, I forgot my negative. And then this was going up, that's a positive. All right, so this will come out -3 if you were to calculate that on your calculator. 414, let's check it out. X, Y, 4 and 14 are my x values. Let's do this one in green just to keep it all pretty. So we're looking at 4, which is 100, and 14, which is down here at 0. So it's definitely negative. Oh, it looks like it's getting steeper than the other two. So first we had -1, and we got a little steeper with -3 if you look at the red line. This one's even steeper, so it should be a greater rate of change. So my rate should be bigger than 3 to 1. Let's see, we are dropping 100. So again, you could do this also if you wanted to. Drop 100 and go over how far? 4 and 14, that's a difference of 10. And that was a positive increase. We dropped 100, but we increased 10 on the x scale in the right direction. So if we divide that, we get -10. Definitely steeper than -3, right? So that one had the greatest rate of change. It said find the average rate of change over the interval shown below. We did that. We are done. End of Unit 7. Good luck on your test.